Today, after multiplying, dividing, and simplifying rational expressions, we are moving on to addition and subtraction. The first thing that we are going to look at are rational expressions that have the same denominator. That means the stuff in the bottom is exactly the same. And, as always, it is the exact same as with fractions. That means with numbers. For example, if you were to look at 2/3 plus 7/3 and want to add these two fractions, then what you simply have to do, you are simply adding the numerators. 2 plus 7 is 9. Now what you have to keep in mind, every time when you reach this step, we always have to simplify. Every time. 9 divided by 3, well, 9 is the same thing as 3 times 3. I am factoring. I will cancel out common factors, and I'm left with my final answer. When we are talking about rational expressions, we always have the letters involved. P over R plus or minus Q over R. The goal here is that R has to be the same. That is the same thing as if you just add or subtract the numerators divided by the same denominator. Let's do a few examples. So here's one. We are supposed to take 3x plus 1 over 7 and add to this 5x minus 6 over 7. I will always do it in the exact same way. I see that the denominators in both cases is 7, and that means that I can take the first numerator and add to this the second numerator, and everything is over this common denominator 7. Now what I'm going to do at the top, I'm going to simplify, and that means I am opening up my parentheses. The second pair of parentheses, if I open this up, then I'm still going to be stuck with 5x minus 6. The positive on the outside didn't change anything. And now I am combining like terms. 3x plus 5x, that will give us 8x. 1 minus 6, that will give us a negative 5. Everything over 7. This top cannot be factored any further. This is the simplified form of my rational expression. If I were to add x squared plus 1 divided by x minus 1 and 5x minus 7 divided by x minus 1. So the same thing as before. They both have the same denominator. And that means all I really do is I add, in this case, the numerators. Placing these parentheses is extremely important, specifically when we are moving on in just a moment with subtraction. In the bottom, I can leave those parentheses away. Let's leave them away. So, again, I open up my parentheses, x squared plus 1 plus 5x minus 7 all over x minus 1. I am simplifying the numerator by combining like terms, and I get x squared plus 5x minus 6 all over x minus 1. And now I step back and I look at this expression and I notice that the numerator can in fact be factored. The numerator on the top right here is the same thing as x plus 6 times x minus 1 all over x minus 1. And now I'm going to see, I can't put parentheses around this in the bottom, and I can think about it, if you want to, as 1 times x minus 1. I'm writing this weird one that hopefully doesn't look like a 7 to you. So what I now can do, I see that there was a factor of x minus 1 in the top and the bottom. And I can cancel this out. And I'm left with x plus 6 over 1. Of course, I don't need to write this over 1 down there. I can just write x plus 6. Let's do another one. One more with addition, and then we'll do one with subtraction. So again, the denominators are really the same, and that means I'm going to have x squared plus 25 minus 10x all over x squared minus 25. I'm opening up my parentheses in the numerator, and now let's do it exactly as before. First, I'm just going to write it as we see it. Divided by x squared minus 25. And now I'm looking at the numerator. There are no like terms, but I can rearrange the terms and write it in standard form. So I have x squared minus 10x plus 25 in the top, and I have x squared minus 25 in the denominator. Now what I can do, and you see now why we have practiced factoring before, the numerator is nothing else but x minus 5 times x minus 5. And the denominator, that was the difference of two squares, that is x plus 5 times x minus 5. And what I see now when it's in its factored form, that x minus 5 was a common factor in the top and the bottom, and they cancel out. And what is left is x minus 5 divided by x plus 5. Now don't cancel anything right here anymore. These are not factors now. These are two terms on the top and two terms on the bottom. As promised, let's do one subtraction problem. Denominators are in fact the same again. So what we are going to do, you see, and now, if you would not put those parentheses up there, you will get a wrong answer. So let's always start this off like this by placing the parentheses. Because if I now open up the parentheses in the numerator, the top, then I will get x squared minus 1. Now this negative sign right here, that is being distributed into both terms, and the signs switch around on the inside. Both the 5x and the 13 become negative. Divided by x plus 2. And as before, I'm going to simplify the numerator by combining like terms. X squared, what do we have? We have a negative 5x minus 14. Divided by x plus 2. When I am at this point, I will always check if I can factor. You see how important factoring is. X squared minus 5x minus 14 can in fact be factored. That would be x minus 7 times x plus 2. And now I have my factor of x plus 2 in the denominator. This factor cancels out, and what I'm left with is just x minus 7. I can just write it like this because the x minus 7 is in the numerator.